Okay, I think we're going to go ahead and get started. So thank you everybody in the audience for attending today. I know it's a late session on the last day. So the topic of today is really, spending some time learning about real-time workloads in banking and financial services, understanding the different components in Databricks that can be used to put together real-time monitoring solutions in the banking industry. And Miracle is going to talk at length and in a lot of depth about how this was implemented. So I'm just going to intro the Databricks components and talk a little bit about what's available and how those are being used. So to introduce myself, I'm Ricardo Portilla. I am an industry principal architect at Databricks. So I spend a lot of time with fintechs that are doing fraud, risk management solutions, as well as customer 360 personalization solutions, and I have done this for about 6 years. Was previously a market surveillance lead at FINRA, so they do securities regulation. They have arguably maybe some of the largest data sets in the world that they have to deal with, all broker dealers, exchanges. So spent a lot of time with things like time series and a lot of those big data workloads about 10 years ago, and have created some open source code. So if you're familiar with things like Tempo or some of those time series libraries, have introduced those into the market, and those are in use at a lot of the capital markets type of firms as well in today. So again, just to contextualize what we're going to be talking about, the three companies that I have here represent retail, media, and the transportation industry, and the really common unifying thread here is that every single one of these companies transformed into a technology company, so digital first, by really just enabling their customers to do everything at the click of a button or just the tap on a mobile app, essentially, right? So retail in 2005 introduced Prime, enabling access to millions of products at everybody's fingertips, as we all know, at Netflix. The number of hours streamed is actually larger than every single rental that occurred at Blockbuster over their entire lifespan. So the ability to do that really came from real-time workloads. And lastly, obviously Uber and Lyft and rideshare apps improved not just transportation, but really mobility. They just completely rethought about how this was done. And a lot of these companies you see here, they're technology companies. They do very sophisticated personalization and pricing and things like that. But the fundamentals of what all these companies were able to achieve is they were able to bring real time to their technology stack. So that means ingesting data in real time, right? Log data in real time, click streams in real time, so they can understand their customers a lot better. And it really comes down to two things. So the two fundamental pieces or components are streaming. So at Databricks, we have Delta Live tables to do managed ETL streaming, data quality as soon as the data lands in your environment. And the second one is Databricks SQL. So once you want to look at your OKRs, look at your KPIs in real time, understand your customers in real time, the first thing you have to do is just monitor all of those transactions. So this is exactly what Databricks is doing. Again, these are the two places that we typically advise our customers to start with, is getting these two components down really well before you do any machine learning. And lastly, the best data warehouse is a lakehouse. This means that today, if you want to consume your open formats, things like Delta Lake, doing it from Databricks SQL is a high throughput, real-time way to consume data. So wherever the data is landing from all of your monitoring solutions, where it's coming in from transactions, you want to consume that with Databricks SQL because you're going to get high throughput. It's going directly against your lake. And we have this whole ecosystem of tools like PowerBI and DBT and other BI tools to access that directly so that you're not having to reinvent the wheel just to monitor your data. So with that, I'll pass it off to Miracle to get into technical implementation.
All right, thank you for being here. It's late in the day. Your presence here means a lot to me. My name is Jian. Most people know me by my nickname, Miracle. I have been in the field of software engineering for about 25 years, mainly focusing on data-driven enterprise application development, and in the last decade or so on data engineering. Currently, I serve as a senior engineering manager at Navy Federal Credit Union, the largest credit union in the world. I lead a data engineering team at our digital department. The story I am going to tell you today started exactly 1 year ago. In June 2023, Navy Federal was about to start the process of migrating millions of users to the latest version of our online banking platform, Omnichannel version 7 online. So we would do it in a controlled manner with small user groups and gradually extending to all of our members over several months. In order to make informed decisions, we needed to closely track how our members interacted with our product. Our engineers created data pipelines to onboard the application log to our data lake. And our data analysts built dashboards and reports to visualize those KPIs. These pipelines run daily, meaning the information from the previous day would be made available to the leadership at the beginning of a new day. The pipelines run as designed perfectly, but in today's world, 24 hours is a really long turnaround time. So as we were moving closer to the first wave of user migration, we decided to enhance our data solution to introduce new insights in near real time. Here's an illustration of the near real time dashboard we needed to create. It has 2 KPIs, super simple. The first was the number of unique members that was able to log into our new channel. And the second was the number of unique sessions the channel served. Additionally, we needed to filter those KPIs on the time dimension and by a member attribute, which was the indicator of which migration wave they belong to. And the expectation was that this dashboard would be updated continuously throughout the day with a latency of no more than 10 minutes. So the mission was pretty clear. The ask was straightforward. My challenges lay time and scale. Time-wise, we only had about 6 weeks from early June to middle July to build a solution from scratch and get it to production. And this is actually the first time my team tried to build a real-time solution in our Azure cloud. So we really had to figure out everything in 6 weeks. And scale-wise, we're talking about billions of application events generated from millions of monthly active users. So this solution must scale as the migration moved along. So in the next 30 minutes or so, I'm gonna share with you our journey to build this solution and the experience we had with Databricks data lake tables and other technologies involved. Conceptually, all our data delivery solutions follow a simple, straightforward pattern. I will break it into 2 parts, right? The left side is all about data ingestion and curation. For every data source out there, we build some sort of data pipeline to ingest the data into our data lake, transform it, make it ready to be consumed by our customers. because of the diversity of the data sources out there, this part is very dynamic. A lot of engineering innovations happen here. And the right side is about data serving and visualization. We use Azure Data Lake Storage Gen 2 as our storage layer, Databricks SQL as our analytical query engine, and Microsoft Power BI for data visualization. Together, they form a simple but effective foundation for data analytics. So we say the left side is for the engineers. The right side is for our analysts. Let's start from the right side, the data source. The data we needed to work with is the event telemetry generated in our online banking application. Our members can perform a variety of banking functions on our online banking platform, such as logging in and out to start with, checking their account balances, making transfers, so on and so forth. Those interactions generate application event telemetry, which is sent to Azure Application Insights. This data allows us to track when, where, and how our members interact with our product. Application Insights offer a variety of built-in analytical tools, but for several reasons, we could not use it as a direct source of our dashboards. The deal killer was that the analytical query engine behind Application Insights has no access to the member attribute data in our lakehouse, which would prevent us from making meaningful filtering on our dashboard. So we must stream the telemetry from Application Insights to our data lake as soon as they arrive to support our use case. First, we need to get the telemetry out of Application Insights. Fortunately, Application Insights has a very handy feature that allows us to stream the logs to Azure Event Hubs, which then allows the consumers that support the Kafka protocol to consume this data with low latency and high reliability. The best part was that it is all infrastructure level setting. There's no coding involved. So we easily put together Application Insights and Event Hubs as a system that can efficiently enable the event telemetry to flow to a data streaming service continuously. All right, so at this point, the streaming source is in place. It's emitting application events 24/7. Now we need to build a data pipeline to get this data into our Azure Data Lake. First, let's take a closer look at the data so you understand what goes into the pipeline and what it is expected to produce. So on the screen is a sample of the message from Event Hubs. As you can see, the messages are semi-structured, nested JSON documents. Each message contains an array of records. And the records represent more than 140 types of events from the Application Insights, with over 100 attributes in total. And here's a catch. The same telemetry may be delivered from Application Insights to the Event Hubs more than once for technical reasons. But we only want to report them once. In other words, we have duplicates to deal with in the source. On the other side of the pipeline, the output is the information specifically curated to store the member login events and optimized to support the real-time queries from the PowerBI dashboard. It should be published as a Delta Lake table in our Databricks lakehouse. To produce it, the pipeline must do 4 things, right? First, persist the raw data in our data lake for long-term storage. 2, flatten the JSON documents into individual application event records so they are easier to work with. And 3, remove the duplicates. Last, tailor the data for the show, which means we need to filter the data down to just the login events and store them in a table that is optimized to serve the real-time queries from the dashboard. We built this data pipeline with Databricks Delta Lake tables. Let's take a look at the first version of the DLT pipeline that we built. What do you think? Not impressed, right? I know what you're thinking. This is, looks a little ridiculous, maybe just barely more complex than the Hello World example you followed maybe last night in your hotel room. It has only 4 tables and 1 view, 1 straight line, not a sophisticated pipeline in the world at all. But I think from an engineering manager's perspective, it is actually quite amazing. It is the cornerstone for our solution's success. I can call it a key ingredient to the secret sauce to beat the time and scale challenge. I will tell you why. Before that, let's take a look at this iceberg. It's not the iceberg we're hearing all day at this time, not Apache iceberg. I think the acquisition of Tabular is screwing up my presentation a little bit because it's introducing a little bit of confusion here. If you don't know what I'm talking about, don't feel bad because I totally made this up based on my experience. In my experience, the effort to build and maintain a new kind of data pipeline from scratch follows the 80-20 rule. About 20% of the effort is spent on implementing what really matters to the business, right? How should the data be transformed to fulfill the business need? And does the data quality meet the expectation? Those are typically straightforward. Your analyst would summarize, write up the transformation logic or the data quality expectation and hand it to you. You as a data engineer just need to turn that into code. Nothing complex here. And then you spend about 80% of your time on the non-functional stuff. If you are an experienced engineer, you should know how much effort is required to productize a data pipeline, to make it scalable, reliable, observable, right? This effort goes beyond just the development. It goes to post-production. It likely goes all the way to the end of your pipeline life. So let's keep this picture in mind, okay? Above the water, everything is simple, but below the surface, a lot of work. Back to our pipeline. First thing is, you can already tell this pipeline is simple. Not only it looks simple, but it was very simple to create. All we wrote was 3 query functions and 2 calls to change data capture functions. The first function we wrote simply connects to the event hubs, apply some very lightweight transformation, and returns a data frame. The second query function takes the complex nested JSON documents and flatten it into individual application event records. And then we call .live tables apply changes function to remove the duplicates. And the third query function, we filter the data down to just the login events, and then select only the columns relevant to login, and then returns the data frame. Last, we call the apply changes function again to make sure there are no duplicates in the login event table. To be honest, recently we figured out this is not required. We didn't even need it, but that's a story for another day. Then we apply the table and view decorators on our query functions to help .live tables understand which data should be persisted, which can stay in memory when the pipeline runs, but not accessible to the outside world. Last, we set data quality expectations on some of the data sets, make sure that we get quality data in our lake and can monitor the health of our data. That's all. 3 query functions, 2 CDC calls to complete all 4 steps. Nearly 100% functional requirements. Simple as that. What does that mean? It means low code complexity and short development time for me. And second, this pipeline was scalable. The omnichannel user migration was iterative. We started with a very small wave, and then we kept increasing the migration size wave after wave. We were anticipating the increasing demand for compute resource, but we were not sure exactly how much was needed for every wave. So when we deployed this data pipeline to production, we turned on a feature called enhanced autoscaling. Set the minimum number of workers to 1, maximum to 5, just let it roll. So for months, this little pipeline quietly did its job, running 24/7. The processing volume ramped up really quickly. From just a few hundred users, maybe a few thousand sessions every day, to millions of users and billions of application events per month, this pipeline automatically scaled the resource up and down, depending on the data volume. Our production support engineers never had to intervene. They practically forgot about it later on. Yeah, number 3, this pipeline was reliable. Between July 2023 and April 2024, in the 9 months, it ran 24/7. It successfully processed about 9 billion application events. On some days, there were hiccups that caused temporary interruptions. Those hiccups were the natural result of being in the cloud environment. They are like unavoidable. They are set to happen. The great thing is that this pipeline showed great resilience. Without any exception, it automatically recovered from those transient errors and chugged on. When there was a failure, our production support engineers would get notifications, so they could start an investigation timely. But so far, we haven't had to do any direct changes on our data pipelines to fix this kind of issues. The manual interventions were mainly on dealing with infrastructure problems. Let's see, network connectivity broken or authentication failures. Once those environmental issues were cleared, the pipeline would start again happily. So that was great for me. Last but not the least, this pipeline was performant. Although the event volume, data volume skyrocketed, the pipeline was able to keep up. The streaming processing speed and the query response time were to our satisfaction. Part of the reason was that Delta Live tables automatically optimizes, compacts, and vacuums the tables it manages. These maintenance jobs effectively eliminates or reduces the small file problem and removes files no longer needed from our storage account. So that yields better query performance. Now, back to our iceberg picture. In my mind, Delta Live tables hides the complexity of modern data engineering under its simple, intuitive, declarative programming model. As an engineering manager, I love the fact that my engineers can stay above the water, right? Focus on what matters the most to the business. The service capabilities from Delta Live tables can take care of what is underneath the surface. It ensured that not only our pipeline was built and deployed in time, but also held up beautifully in the long run. The last mile of our journey was the delivery of the dashboard. At Navy Federal, our digital data analysts utilize Microsoft Power BI to provide reporting capabilities to various departments. Databricks SQL allows us to query data with speed and at scale. Through Azure Databricks connector, our analysts connect Power BI to the data in our data lake through the Databricks SQL endpoint, build Power BI semantic models, and create insightful visualizations. The key to enable real-time data visualization is Power BI's direct query capability. Instead of importing data to the semantic model on a predetermined refresh schedule, our dashboard directly queries Databricks when the visuals are rendered, bring back the latest update to the users in real time. The timely release of the real-time user activity monitoring dashboard combined with historical views that unveils long-term trends received overwhelmingly positive feedback from our senior leadership and the stakeholders. It was a huge success for us. And looking back, we were able to complete our proof of concept in a week. Develop, test, and figure out a CI/CD process in 3 weeks. Deploy the pipeline to production just before the start date of the first wave of migration, and release the dashboard just a few days later. The simplicity of Data Lab Tables programming model, combined with its service capabilities, resulted in an incredibly fast turnaround time. It truly allowed us to get a whole new type of workload to production in a record time with good quality. Right? Hopefully, the choice of selecting our very first version as an example now makes a little sense to you. Of course, our story did not stop there. After the first version of pipeline went to production, we would continue to innovate. Fast forward to today, the Data Lab Tables pipeline engineering practice at digital data engineering is elevated to a whole new level by developing and deploying a metadata-driven framework. The great thing about Data Lab Tables is that it has a clear and concise Python API and seamless integration with the Spark SQL API, which allows us to inject virtually anything we want. That includes our opinion on how a data pipeline should be structured, our established data processing patterns. All this stuff we can inject into the DLT pipeline programmatically. Combining the simplicity of the DLT Python API, the power of Spark SQL API, the expressive YAML, and a magical library called Pydantic. Within just about 300 lines of code, we were able to bring a no-code experience to our DLT pipeline development with our homegrown metadata-driven framework, DLT Entity Generator, also called DIG. With a well-defined configuration schema, our engineers are able to describe all aspects of a DLT pipeline in YAML format without writing any Python code in most cases. DIG understands those descriptions and automatically generates the code, the DLT instructions to do the job. Regardless how many data pipelines we maintain, essentially we're just running different YAML files through exactly the same engine. Here are some features of our solution. First, it supports all data source types accessible through the Spark Data Frame Rater or Data Stream Rater APIs. If you can provide the connection options, DIG can connect to the source. And second, we can declare or describe DLT objects like tables, views, data quality expectations, or how we would like to do change data capture in YAML file. DIG will generate those objects accordingly at runtime. 3, I think this is the biggest one for us. We specifically enhanced support to data quality expectations. Now we're able to capture, persist the data quality expectation evaluation results at a raw level and use it to orchestrate our data flow and perform some sophisticated data quality monitoring. For example, we can quarantine the bad data into separate tables so we can use it for future investigation. We can also compute aggregated data quality metrics. We can conveniently parameterize our Data Lab Tables pipeline by referencing Spark configuration options in our YAML configuration file, easily adjust the pipeline behavior when it is deployed across multiple environments. We can also refer to Databricks secrets to access protected resources without worrying about exposing those secret sensitive information as plain text in the configuration file. These YAML files are published through Databricks repos integration. Dig can load those configuration files from workspace files as workspace files. This makes our CI/CD process very straightforward. And last, Dig solution works nicely with regular DLT notebooks. For any use case that is not yet covered by our solution, we can combine them as implement that as regular DLT notebooks combined with Dig solution in the same DLT pipeline, it will just work. So the first thing we did after Dig was released was converting our first DLT pipeline with it. We fully replicated all the functionality of the first version and added a whole bunch of data quality enhancements. All it took was a week end-to-end to get to production and run beautifully. In fact, the actual conversion took probably less than an hour. Most of the time went through the CI/CD, code review, tinkering around how we want to control the expectations. That was roughly 85% time reduction with more functionality delivered. So having a metadata-driven solution gives us the ability to deliver more data pipeline with less code, but a lot more consistency. Ultimately, that gives us greater engineering scalability. So if you are, like I mentioned, this homegrown metadata-driven framework only took about 300 lines of code to implement. We wrote probably another 300 lines of code to test everything thoroughly. But compared to the effort required to build such a thing, the reward was phenomenal. So if you are thinking about using DLT to power your future data pipeline, I would definitely recommend adopting a metadata-driven approach. You may consider DLT meta, DBT, or just roll your own solution if you have a strong opinion on how this thing should be done, like we did. All right. Now, forgive me for my poor taste of color, but I will say, in summary, Delta Live tables isn't a silver bullet. You just can't use it for every data pipeline. But for us, it worked wonderfully for our use case. I'd like to wrap up my presentation with the top 3 things we like the most about Delta Live tables. 1, it's simple programming model, which gives us speed to market. 2, it's built-in scalability, reliability, and automated optimization that greatly simplified our operations. And number 3, it's extensibility through the API, which gives us a whole lot of space for engineering creativity and scalability. With that, thank you very much for your attendance. You're welcome to connect with us on LinkedIn. Here are the QR code, and let's stay in touch. Thank you very much. Thank you.